Hi, once again with a new video. I'm Viraj and this is my YouTube channel Maths by Viraj. Previously, I uploaded a video on the simultaneous equations, and the method which I used to solve simultaneous equations was the elimination method. Today, I am going to teach you all from this video the method of substitution, that is, use a substitution how to solve simultaneous equations. Just in case if you could not see my previous video on the simultaneous equations, you can go to the link below in the description, or you can go to the link over here and see it. Remember, subscribe Maths by Viraj and click on the bell icon so that you will be notified as soon as I upload a new video. Right, children, now let's look at the two equations on the board. The first equation is x plus 3y equals 5, and the second equation is x plus 2y equals 10. Right, let this be my equation number 1 and let this be my equation number 2. Considering equation number 1, I can write x plus 3y equals 5 and x equals 5 minus 3y. Now you can see that from the equation x plus 3y equals 5, I have come up with an expression for x in terms of y. Plus 3y, when it's taken to the other side, it becomes minus. Therefore, x can be written as 5 minus 3y. This is my equation number 1, and the derived equation I can take as equation number 3. Now, for the second equation, I can substitute 5 minus 3y for x in equation number 2. For equation number 2, instead of x, now I can substitute 5 minus 3y. This is the reason why we call this method the substitution method. Now, the equation that we have is x plus 2y equals 10. Now, instead of x, I can substitute 5 minus 3y from equation number 3. 5 minus 3y plus 2y is 10, which is 5 minus y equals 10. Minus 3y plus 2y is minus y. Minus y is 10 minus 5. Minus y is 5. Now, when it is minus y here, we can assume that it is minus 1y. Y is equal to 5 divided by minus 1, and the value of y is minus 5. When the value of y is minus 5, we can very easily find the value of x. Now, we can substitute minus 5 for y in equation number 3. Now, you can see that equation number 3 is x equals 5 minus 3y. Therefore, we have found the value of y to be minus 5. X is equal to 5 minus 3 multiplied by minus 5. Then x equals 5 minus into minus plus 3 into 5, 15. Therefore, x is equal to 20. Now you can see, children, I have very easily found the answers for the variables x and y using the method of substitution. Right, children? You saw how I got a value or an expression for x in terms of y and used the method of substitution to solve the simultaneous equations. But you might have a question as to why did I make x the subject and why did I choose equation number 1, 5. Suppose I use equation number 2. X plus 2y is equal to 10. X equals 10 minus 2y. This is my equation number 2 and this is my equation number 4. Yes. According to these simultaneous equations, it's very easy to come up with an expression for x in terms of y. And you will get the same answer. But what if I made y the subject? Now, if you substitute x as 10 minus 2y to equation number 1, you will still get the same answer. We'll do it then. X plus 3y equals 5. Instead of x, I can substitute 10 minus 2y. 10 minus 2y plus 3y is 5. 10 plus y is 5. Y equals 5 minus 10. Y equals minus 5. Now you can see that we still get the same answer. But again, the question arises, why I chose x to be the subject and not y? Fine. If I chose equation number 1, x plus 3y is equal to 5. 3y is equal to 5 minus x. Y is equal to 5 minus x over 3. This is from equation number 1. If I choose equation number 2, x plus 2y is equal to 10. X equals, 2y is equal to 10 minus x. Y is equal to 10 minus x over 2. Now you can see, unlike the equations that we derived, if I use equation number 1 and made x the subject, I have a direct, very easy expression. X equals 5 minus 3y. But if I made y the subject, I have it in form of a fraction. Children, please understand, as kids, it will be much easier if you chose an easier path to solve the question. Similarly, if I choose equation number 2 and made x the subject, again I have a linear expression. But if it is in terms of y, I have a fraction. So this is the reason why we choose specific equations and specific variables are made as subjects to make the method of solving the equation much easier. Right, children, let's look at another example. Here I have t minus 4p is equal to 10. Let this be my equation number 1. 2t plus 6p is equal to 20. Let this be my equation number 2. 5. Now let's try to find out all the possible derivations or expressions that we can get. If I consider equation 1 and if I make t the subject, what is it that I am getting? T minus 4p is 10. T is equal to 10 plus 4p. Yes, this is an expression. We'll mark this as equation number 3. Similarly, if I use equation number 2 and also made t the subject, it is going to be as 2t plus 6p is 20. 2t is 20 minus 6p. T is 20 minus 6p over 2. T equals 10 minus 3p. Let this be my equation number 4. Similarly, let's consider equation number 1 and make p the subject. When I make p the subject, it is going to be t minus 4p is 10. I can write this as t equals 10 plus 4p. T minus 10 is equal to 4p. T minus 10 over 4 is equal to p. Fine. If I use equation number 2 and make p the subject, it's going to be 2t plus 6p is 20. 6p is 20 minus 2t. P is equal to 20 minus 2t over 6. Let this be my equation number 5 and let this be my equation number 6. Right, children? Now at a glance, you can see that making t the subject and getting an expression for t in terms of p is the most easy method to solve the simultaneous equation. Now you see that this is t equals 10 plus 4p and this is 10 minus 3p. Fine. But if you look at the working, this particular working 2t plus 6p is equal to 20. This working consists of more mathematical parts. Therefore, it's good, if it's wise, if we could use the first equation, t minus 4p equals 10 and t equals 10 plus 4p. The reason is, the lesser the work that you have to do, the lesser or the possibility of that you making a mistake is minimized. Fine. So if I choose equation number 3, now remember I derived equation number 3 from equation number 1. Therefore, whatever the derivation that I have got for t in terms of p, now I am going to substitute it to equation number 2, because equation number 3 was derived from equation number 1, and to get the values I am going to substitute this not to equation number 1 but to equation number 2. Now substitute 10 plus 4p for t in equation 2. Now 2t plus 6p is 20. Instead of t, I am going to substitute 10 plus 4p. Therefore, 2 times 10 plus 4p plus 6p is 20. 20 plus 8p plus 6p is equal to 20. Now, what have I got? 20 plus 14p is 20. 14p is 20 minus 20. 14p is 0. P is 0 divided by 14. P is equal to 0. Now, you can see, children, that I have got a value which is 0. Fine. Don't worry that if you get an answer as 0, no, you can get answer as 0. Now, how am I going to get the value of t? Again, substitute p equals 0 for equation 3. What is my equation 3? T is equal to 10 plus 4p. T is equal to 10 plus 4 times 0. T is equal to 10 plus 0, and value of t is 10. Children, I hope you understood today's lesson, and further details are given in the description below. Share this video among your friends, and don't forget, subscribe Maths by Viraj and click on the bell icon so that you will be notified as soon as I upload a new video.